Okay, who's up for a little more fun with rationals? I'm going to start with my equation, same as always. It's some kind of a fraction, and the factors in that fraction are determined by the features in the graph. So let's start off with blue, and I'm going to go after those x-intercepts. I see only one of them, and it is a bouncing x-intercept, which makes it even. Okay. In other words, it's going to have an even exponent when I put that factor in my equation. So that's going to be x, oh, it's not x plus 2, right? That is x minus 2 squared. Okay, I suppose I could say x minus 2 to the fourth. That would create some problems. Let's just stick to 1 and 2 as our possible exponents. Next thing I'm going to look for, let's talk about the horizontal asymptotes. Okay, those are located, the vertical asymptotes are located here. There's one. And that's going to be a value of, well, I'll keep it on the right side just so we keep everything straight. That's x minus 4 as a factor. And because it is odd, it has a single exponent right here of 1. How do I know it's odd? Well, take a look. Left on the bottom, right on the top. That's why it's odd. Okay, great. That one's done. Now let's talk about this vertical asymptote over here. This one's a little tricky. So first of all, it's located at positive 1, which makes its factor x minus 1. But what's interesting about it is this guy is actually even. Look, it goes down on the left and down on the right. That's symmetric behavior. That's an even asymptote. So what it means is we have an exponent right there. Vertical asymptotes don't exactly bounce, but this is as close as they get to bouncing. So that's pretty good. Now there's still a hole in this function sitting around like a little goober right here. So that guy, we're going to take and put it into the function as a factor that appears on top and bottom. So the x value is 3, so I'm going to say x minus 3 on top and x minus 3 on bottom. And we don't have to worry about the exponents there. Not that you couldn't have an exponent. I mean, it's possible. But I made these problems, and I didn't put any exponents in there because I consider that a little below the belt. Okay, that's just a little too tough for what we want to go over. And there's one piece left. There's that vertical scaling factor on top. I don't know what it is. Let's just call it A. To find A, you have to plug in a non-zero y value. Pick any non-zero y value you like. If you want, you could pick, oh, I don't know. Let's find something. Now, there's not a whole lot of nice things, but I guess you could pick the hole and you could plug in the hole. But, why make it hard? Why don't we just pick the one that's already made for us right here? Okay, that y-intercept is located at 0, negative 6. Okay, we're going to plug that in over here. So negative 6 equals a times 0 minus 2 squared, 0 minus 3, divided by 0 minus 1 squared, 0 minus 4, and 0 minus 3. Okay, so now simplify both sides. Negative 6 is easy. On the right side, we've got 4, I think that's negative 12 on top. And on the bottom, it looks like a positive 12 once things simplify, which means cross out some 12s and we get negative 6 equals negative a, so a equals 6, and we plug this into our equation, and we'll be done at this point. So I have 6, that's my vertical scaling factor. I have my x-intercept, which is even. It's a balance at x minus 2 squared. Then there's a hole at x minus 3, top and bottom. And then I have two vertical asymptotes, x minus 1 squared, that was the even one on the left, and x minus 4, not squared, that's the odd one on the right. So there you have it.